This is CS1101 Lecture 4.2. We're going to be digging a little bit deeper into the boolean type and methods which return a boolean value. So we've been talking about booleans for a little while now. Specifically, we've been dealing with the if-else statements, or our conditional logic. But let's look at the boolean type a little bit more deeply. So the boolean data type is a primitive data type, which means that it is a native data type to Java. So it is not a combination of other data types, it is a foundational native data type. And it is used to represent logical values of either true or false. So the only two possible values for a Boolean variable to take on is either true or false. So any Boolean expression is going to evaluate to a value of true or false. The conditions and if statements and loops are all Boolean expressions, so they always evaluate to a Boolean value. But you may not be aware that you can store these Boolean values in variables that are of Boolean type. And you can pass a Boolean variable as a parameter. And you can also return Boolean values from methods, just as we have with other data types. So here's an example where we're declaring a variable called not legal, and this variable has the data type Boolean. So this variable is only going to be able to take on the value true or false. And then we're assigning this variable whatever results from the expression age less than 21. So if the value stored in age is less than 21, then the value which is stored in not legal will be true. However, if the age is greater than 21 or equal to 21, then the value which is stored in not legal will be false. Now, in the next statement, we have a Boolean variable called loves CS, and it is assigned the value true. So we have seen so far we can declare integer literals. So if we have a variable called num and we assign it, it's an int, and we assign it the number 5, and that's supposed to be a semicolon, but it looks more like a J. We assign it the number 5. We call the 5 an integer literal. So directly coding true here would be a Boolean literal. But notice one of the cool things now. Rather than coding this test into the if statement, we can store the result of this Boolean expression in the variable not legal, and then in our if statement we can actually use the value stored in the Boolean variable as part of the test. So here, if we have either not legal or does not love CS, then they are not allowed into the club. So let's just say that our number is 20, age is 20, then not legal is going to take on the value true, while love CS will take on the value true as well. So when we get to our if statement, not legal is going to evaluate to true because the value true is stored in the variable not legal. Now, we've discussed already that anytime you have the logical OR operator and any of the operands evaluates to true, it will short circuit the rest of the operands. So it wouldn't even bother to look at whether or not we love CS because it already knows we're not allowed in because we're not legal. So sorry, you can't enter. So we were able to store the results of this logical test in a variable and use that variable in our if statement rather than doing the logical test actually in the if statement. And this is the exact same. The code and the functionality here is precisely the same. The only benefit is that this is somewhat more readable. We can tell what's happening here. Not legal. If you're not legal, not allowed in. Oh, makes sense. I can read that and I can understand it intuitively. So here's a short list of reasons why the Boolean type is useful in programming. But to be honest, the Boolean type is the fundamental building block of programming at its very most basic. Consider, each memory location in a computer is fundamentally made of bits. Each bit stores a value of either 0 or 1. Fundamentally, the computer is built on Boolean values. So the Boolean is important to computing because it is the fundamental building block of computing. But it is also useful even in higher level programming because we are able to perform logical tests. So we're able to, write out some Boolean expression that evaluates to either true or false, and we're able to capture this result from a very complex test into a single variable that stores a simple value of either true or false. And then we're able to pass that around to other methods as a parameter, and we're able to return it as a return statement. So that's pretty useful because we could write a method that does the complex test and returns the Boolean value. So I'm kind of skipping around here, but we've talked about 1, 4, and 3. And also, as I alluded to in the previous slide, by capturing the result of a logical test into a Boolean variable, oftentimes that will make it more easy to read what is actually happening in the code. So, we did a test to see if the age was less than 21, and if it was less than 21, we would store the value true and not legal, right? So we stored the result of the logical test, is the age less than 21, in the variable not legal. Then, in our if statement, rather than just coding in directly is age less than 21, we simply put in if not legal, not allowed in club. And this is transparent. What I mean by transparent, someone who was not part of writing that code could come behind us, see the code, understand exactly what it was meant to do, and in this way it is more maintainable. We've mentioned this, but to make sure that it's fresh in our minds, the following built-in string methods return Boolean values of either true or false. So equals is a method built into the string class, which will compare the string which is stored in the variable called str, which is just a placeholder for whatever parameter you happen to pass to it. It will compare the string which you pass to it to the string stored in the object which is being used to access this method. So that language may have been a little bit confusing, but what I mean is if we have some variable called name, and name is a type string, we can say name dot equals, and then we can give it a string literal or another string variable, John. And this would return a value of either true or false based on if the value stored in name was equal to the string John. And we could capture that returned value into a Boolean variable if we so chose. Others that we've talked about, equals ignore case. So this is the same as equals. However, in this particular version, the method will ignore the case and just look at the individual letters without considering case. Starts with is a way to evaluate whether or not the string name starts with the string which we pass in str. Ends with is the opposite. So if we did name dot ends with and then passed it some string, we would it would be checking to see if the last characters of name matched the characters stored in the string which we pass to the method. So these methods are actually returning a Boolean value. So just like in previous methods when we calculated the BMI of someone and returned the double, returned a double value containing the BMI, these methods are calculating some logical result, such as if two strings are equal, and they're returning that result as a Boolean value. So here's an example program. We're trying to write a method to determine whether or not two integer variables are both odd. And we are going to return a Boolean value that is true if both are odd and is false otherwise. So we're going to declare our method, and so here's our method heading. We're going to have public static, and then the return type will be boolean. The name of the method will be both are odd, and we're going to have two parameters, which is int n1 and int n2. Now, rather than having multiple returns, we will declare a variable called both odd of type boolean, and this is where we're going to store the result of our logical test. So if n1 mod 2, so remember, if n1 mod 2 is equal to 0, that would mean that n1 is even. So if it is not equal to 0, that would mean that it is odd. So if n1 mod 2 is not equal to 0 and n2 mod 2 is not equal to 0, then both are odd. However, if this statement is false for any reason, then both are not odd. Then we will return the value which is stored in the variable both odd. So as a tip, you don't have to capture the Boolean value which is returned by a Boolean method. If you're going to use the Boolean value returned by the method in an if statement, you can actually use the method call as the test. So we said in every if statement there is a test, right? That test is a Boolean expression. You can actually call the method in the test. And so this call is going to return a value, and that value will be the results of the expression. So if this method returns a value of true, then we will execute the contents of this if statement. If this method returns a value of false, then we won't execute the statements following the if statement. So that's a convenient way, and it's very readable as well if you have named your methods appropriately. So it's easy to read if both are odd. We didn't even have to comment it. It reads extremely well because the method is named appropriately. So if this is your first time using Boolean methods and writing Boolean logic, there's a good chance you might wind up writing something like this as a test in an if statement. A call to the method both are odd with the logical operator is equal to true. Understand, both are odd, or both odd, is going to return either a true value or a false value. If it returns true, then true is equal to true will also be true, and therefore the if statement will execute. If it returns false, false is equal to true will be false, and therefore it will not execute the if statement. It's redundant. It is never necessary to check if something is equal to true in an if statement. That's the point of the if statement. So this is bad. Poor style. That is functionally the same as the previous. So a better way of going about the same code above, the same as the code above, would be to just say if both odd, and then whatever statements you wish to execute in the situation where they are both odd. This is the way that we expect you to code in this class. You wouldn't lose tremendous points for this, but it is bad style and you would lose some points because it shows a basic misunderstanding of how Boolean expressions evaluate. Also, don't test for false. Don't say both odd is equal to false. This is not appropriate. That's not the right way to go about it. It will work, don't get me wrong. It will compile, it will run, and it will function. However, it's not very readable, and that is a problem. That's a very real problem. So rather, a better way to go about this would be if not both odd. So here we're just negating the value which is returned by both odd. So in the first statement, we wanted to know if both were not odd, right? So we said we were calling both odd, and then we were going to compare the result of this to is equal to false, in which case we wanted to do some set of statements. So we were looking for the situation where one or both of these numbers was not false. Much easier way to do that is simply to negate it. So not both odd. It's common for Boolean methods, so methods which return a Boolean value, to contain some sort of if structure. And this if structure decides whether to return a value of true or false. Again, this is less than optimal because there's an easier way to go about it and a more readable way to go about it. So first of all, we can perform the test and store the result of the test in a variable called isEven. So we're checking to see if this integer is even. And rather than performing the test in an if statement and then storing some value and then returning that value, we can simply perform the test. So we will do n1 mod 2. If this value evaluates to 0, then we know that n1 is even. So we're checking n1 mod 2 is equal to 0, in which case, if this evaluates to true, is even is true. And then if is even is true, we return the value true. However, if this is not the case, we will return the value false. I would say this is somewhat better, but it's sort of a lateral move. We can do better. Okay, let's think about this. The if-else was really unnecessary in the previous logic. Let's look at why. We were already doing this test to see if n1 was even. n1 mod 2 is equal to 0. We'll evaluate to true if n1 is even, and false if n1 is odd. So we have the value is even. Okay. Why can't we just return is even? Why do we need to have an if statement to determine which to return? Think about it. Is even will be true if n1 is even. So then when we return is even, this will return the value which is stored in is even, and that value will be true if n1 is in fact even. However, if n1 is odd, the value which is stored in is even will be false, and therefore, when we return is even, it will return the value false. So this will accomplish exactly the functionality we wanted. It will check to see if n1 is even and return true if it is and false if it's not. This is much cleaner. This is much less code. And you may be thinking, actually, do we even need the variable? Do we even need to actually store the result of the test in this variable is even? You're right. We don't actually need that. We could simply perform the logical test and return that value. So a return statement has the keyword return followed by an expression which should evaluate to the data type defined in the method heading. So we have an expression which will evaluate to a Boolean value, which is the return type we've declared. So n1 mod 2 will give you an integer. Then we are comparing that integer with the integer literal 0, and if they're the same, this will evaluate to true. And we will return the value true. And that will be true if the number n1 is even. So this is an even cleaner, better way of writing this same code. And it's only one line. So now, where before we were using an if statement to decide whether to return the value true or return the value false, we don't need to do that. So we have this method, public static, we're returning a Boolean type, and it does something, and then we do some test, and we return some Boolean value. That is completely unnecessary. If we're going to have to perform a test in an if statement, we can simply return the value which results from the Boolean expression. So in the bottom we have the cleaned up version of the code from above. It's less redundant and much cleaner. So public static, return type is Boolean, and then it's some function with some parameters. But then the test that we were using above to decide to return true or false, now we are simply returning the evaluation of this test. So we have our return statement, and the expression in our return statement is the test which we were previously using in our if statement. So let's do some Boolean method writing practice. So let's write a method which is named isVowel and returns whether a string is a vowel. And this should be case insensitive, so a capital A is a vowel just as much as lowercase a. Really try to write good Boolean logic and a clean method. So as example runs, isVowel given the string lowercase q should return false. IsVowel given uppercase A should return true. IsVowel given lowercase e should return true as well. So pause here and write out a method which you believe will accomplish this functionality and return a Boolean which is true if the string passed to the method is a vowel and false otherwise. So here's a nice method to determine if a string is vowel. So we've declared the method. We have our method heading, public static, return type Boolean. The name is vowel. That's what we said in the requirements. It had to be named is vowel. It takes a string as a parameter. We have it commented. Everything looks good. All right, so let's look at how it functions. So we have one statement. It's a multi-line statement, but we have only one statement. It's a return statement. So we have the keyword return, and then all of this is a long Boolean expression. But it's very readable because of how we have used carriage returns. So it is not overly cumbersome to look at and figure out what is happening. So we're going to check to see if the string which was passed is equal to, without considering case, the letter A. So remember how we are affected by short circuit evaluation. So this is a Boolean expression. If possible, this expression will short circuit. So if this first expression in the overall expression is true, then we know that the entire OR statement will be true regardless of the rest of the values. So if it turns out that S contains either an uppercase or a lowercase a, we won't evaluate any of the rest of these statements. We will immediately short circuit and return the value true. However, if that does not occur and this is evaluated as false, then we know nothing. We can't short circuit, we can't make any assumptions. So we'll move to the next portion of the expression, moving from left to right because these operators are at equal precedence. So we will check to see if it's an uppercase or lowercase e. If not, we will check to see if it's an uppercase or lowercase I. If not, O. If not, U. So if all of those tests fail, then the value of this expression is false, and we will return a false. If any of these is true, we will return true. So we have successfully coded this. It works. We went through the logic, and it's very clean with a single statement. Now, based off what we know about De Morgan's theorem and introduced in the previous lecture, how might we change this method to make it into is non-val? So in this case, we would want to return true when we passed a Q, but false when we passed A or E. So take a second, rewrite your method, pause the video because we will move quickly on to the answer. So here we have a very similar method to the one we looked at a moment ago. It's public static and the return type is Boolean. The name is non-val, and it accepts a string parameter, and this parameter is called s. We have one statement, it's a return statement, and we have a Boolean expression which will evaluate to some Boolean value. So using De Morgan's theorem, we have to negate every expression, and we have to change every or to an and. So if you notice, that's exactly what we've done. We now have s dot equals ignore case, which is negated, so not s equals ignore case a, and then where before we had an or, now we have an and, not s dot ignore case e, and so forth. So remember now, short circuiting is based on a false statement when we're using a logical and. So if this first expression, were to evaluate to a false value, then we wouldn't evaluate any of the rest of the expressions involved in this Boolean expression, and we would short circuit and return the value false. However, if this evaluates to true, which means the string stored in s is not an uppercase or lowercase a, then we would move to the next expression, and if the value stored in s was not an uppercase or lowercase e, we would move to the next, and so forth until we check u. In the situation where we have checked all of these and the character stored in s, or the string stored in s, is not equal to any of these vowels, then we will return the value true. However, if any of these tests returns a value of false, then we will return false, in which case it is false that this string is a non-val. So for instance, if s were equal to the letter A, then the method equals ignore case would return true, but we are negating it, so that true would become false. And since false will cause logical and to short circuit, none of the rest of the expressions will be evaluated, and we will immediately return false. And that makes sense, right? If s contains a, then it is false that a is a non-val. Another way you could go about this is simply by by making use of our isVal method. So we could have simply had a return statement that was return negate isVal. And I'll leave that to you to figure out why that would work. So now let's do one more exercise. Choose one of the following to write up on paper. So either write a Boolean method to decide whether two words rhyme, and we will decide whether two words rhyme based on if they have the last two letters in common, or detect if they alliterate, and we will decide if two words alliterate based on if they begin with the same character. So pause and attempt to write out one of these methods. So here are two methods to accomplish what we've described. We have a method called rhyme and a method called alliterate. Both are declared as Boolean methods. So let's look at rhyme. We're going to pass string S1 and S2, and what we're really after, so we're talking about whether they rhyme or not, but let's make that concrete. What we're really after is whether or not the two words end in the same two letters. So we need to get access to the last two letters of one of the strings. So to do this, what we're going to do is declare a string variable, and we're going to call it end of word 2. And we're going to assign it the value. Now, this is an expression which will result in a string value. So we're assigning end of word to whatever results from the evaluation of this expression. All right, let's look at the expression. So we are going to access the object S2, which is a string, and we're going to use the substring method, and the substring method will return a string. And if you remember, substring, you have to define either a start location or a start and end location. So this particular usage of substring is only supplying the beginning index. So this version of substring will return the string from this index until the end of the word. So what we need to do is we need to find the last index and back up 2 letters. So consider what we're doing. Imagine that we had the word hello, and we said, what's the length of the word hello? The answer would be 5. So we subtract 2 from 5, and remember, the way that strings work, the indexes are 0 based, so 0, 1, 2, 3, 4. So length will give us a value of 5. We subtract 2, so we will be looking at index 3. So we will get the substring, which begins at index 3 and goes to the end of the word. So we are returned the string LO. So this code effectively gets the last 2 letters from the word, or gets the last 2 letters from the string, which is stored in the variable S2. Then, in the return statement which follows, we have an expression which checks to see if the end of string S1 ends with the string end of word 2. So imagine that S1 contained the word jello. So in this situation, end of word 2 contains LO, and we are checking to see if string 1 ends with LO. This will return true. So our rhyme method returns true if the 2 ending letters of both words are the same. This is exactly what we wanted to happen. Notice in the alliteration method, we have public static, return type boolean, alliterate. We're going to pass in the same 2 parameters, string S1, string S2. But it's a little bit easier. So we're going to use substring again, but in this situation we're going to use the variant where we supply both the beginning and the ending index. So in the situation where we use the word hello, the beginning index, to obtain the first letter, the beginning index is 0. And the way that substring works when you supply a beginning and ending index is it will return the string which begins at the beginning index and terminates one before the ending index. So in this situation, it's only going to return the letter H. So s2.substring01 is just the letter H. And then we are using the built-in method to the string class starts with, which is very similar to the ends with method. So we are evaluating if S1 starts with H. If that evaluates to true, then this method will return the value true for whether or not these 2 strings are alliterative. And if they do not start with the same letter, then it will return the value false. And this is exactly what we want. This works perfectly. Here's an example main method that would make use of these 2 alliterate and rhyme methods that we have just defined. So we have a comment that describes what the program does. We're importing Java util because we want to be able to have a scanner to be able to get user input. We have defined our class, and we have our main method. So we define a scanner object called console to be able to get input from the user. We prompt the user for 2 words. We use the scanner object console, and we use the next method, which is part of that console object, that scanner object, and this returns the whatever the user types in next as a string. So understand that this is a string. It evaluates to a string. So then we're able to access the toLowercase method, which is part of the string class. So this converts the string which the user typed in to a lowercase string, and we store that into the variable word1. We're going to do the precisely same thing for word 2. Now, if they rhyme, we want to print out they probably rhyme. If they are alliterative, we want to print out they alliterate. So to do this, we're going to make use of our handy-dandy rhyme test and alliterate test. So we say if rhyme, and we pass the 2 parameters, word 1 and word 2. We print they probably rhyme. To test if they alliterate, we do if alliterate, and then 2 parameters, and they alliterate. So in this way, we're able to much more elegantly test to see if these 2 words rhyme or alliterate, and we have created a main function that reads as a summary of the program and is readily maintainable because of the readability and transparency of the code.